Okay, so today we're going to talk about trapezoids and isosceles trapezoids. Just to kind of refresh your memory, so remember we've had this table of the quadrilaterals, and then specifically we had parallelograms, and then so parallelograms are quadrilaterals, and then we branched off from here, and we had rectangles, and we had rhombi, and then we had a square, which was both a rectangle and a rhombus. So where do trapezoids and isosceles trapezoids fit in? Well, they are not a quadrilateral, or they are not a parallelogram. So trapezoids are their own little unique bird over here because they are not parallelograms. So trapezoids are over here, and then you have isosceles trapezoids. Okay, so trapezoids are not parallelograms. So the definition of trapezoid or what a trapezoid is, it is a quadrilateral with one pair of parallel sides. So again, unlike parallelograms have two pairs, this only has one pair. Okay, so if we have a trapezoid, I'm going to really exaggerate it here. Okay, so if I have a trapezoid, that means these are parallel. One of the properties that happens is because these are parallel, it goes back to when we had parallel lines and the relationship between these two angles. And that was the fact that because we had parallel lines, these were called consecutive interior angles, and they had a relationship of equaling 180. It's no different here. Because we have the parallel lines, these two angles will equal 180 degrees, and these two angles will also equal 180 degrees. So we would say that consecutive angles are supplementary. Okay, also in trapezoids, I'm going to kind of clean this up a little bit. Okay, so not only do we have parallel sides, the parallel sides are called bases. Okay, so this would be a base, and this would be a base. Okay, we also have what are called base angles. So we have something to talk about. So angle A and angle B would be considered a pair of base angles. And angle C and angle D are a pair of base angles, or are base angles. That's going to be especially important once we get to the isosceles trapezoids. Okay? So, trapezoid, you have one pair of parallel sides, and then we have consecutive angles are supplementary. So let's do an example of those. This as example 1. Okay? If we have B, D, E, and F, just so we have something to talk about. If we want to find the missing angles, so if I know that Let me figure out a good example here. These are all. I don't like any of those examples. If we know that angle B is 120 degrees and angle D is, we're going to say 110 degrees, then we have enough information to find angles E and angles F. So that means that these two would have to equal 180, and these two would have to equal 180. So we would be left with this being 60, and this angle being, brain part here, there we go, 70 degrees. So what do we know about, this is a quadrilateral. So any quadrilateral has a sum of angles equal to 360 degrees. So let's do a quick check. So 120 plus 60, that gives me 180. 110 plus 70, that gives me another 180. So my angles do all add up to 360 degrees. I want to do another example, and that is I'm going to actually go on to isosceles trapezoids, I think. Okay, so in isosceles trapezoids, obviously because it is a trapezoid, it has the characteristics of a trapezoid. So we only have one pair of parallel sides. Consecutive angles are still going to be supplementary. But now we have some unique stuff that happens with an isosceles trapezoid. So by definition of isosceles trapezoid, so there's my parallel sides, my parallel bases. The sides that are not bases are called legs. So this is a leg, and this is a leg. And in an isosceles trapezoid, the legs are congruent, and base angles are congruent. Remember we talked about those pairs? So that means that these two are congruent, and these two are congruent. So these are congruent, and these are congruent. So base angles are congruent, the legs are congruent, and there's something else that's going to happen, and that is the fact that opposite angles are supplementary. Oops, I'm running out of room here. Supplementary. Okay, so that means that if we go back to, let's make this M, N, O, and P, that means that the measure of angle P plus the measure of angle N will equal 180 degrees, because these are opposite. And it also means that the measure of angle M plus the measure of angle O are going to equal 180 degrees. And the last thing that is true in an isosceles, I'll use a different color, and that is that the diagonals are congruent. Okay, diagonals are congruent. Let's do a couple examples of isosceles trapezoids. I'm running out of some good examples here. Hold on. Okay, so I want to get some algebra involved. So this one's going to be example 2. And we know that we have an isosceles trapezoid. And you would know that because you're going to be given the fact that the legs are congruent. So we have this scenario, and we have that this angle is 28x minus 11, and this angle is 51. So you got to think about what's the relationship, and that is that they are opposites. So opposite angles are supplementary. So 28x minus 11 plus the other angle of 51 is going to equal 180 degrees. So 28x plus 40 equals 180. 28x equals 140. And I'm going to grab my calculator. So that means that x equals 5. So if x equals 5, let's say I was actually asked to find the missing angles, I would plug this back in, know that these are supplementary. We would know that this angle is also 51 because base angles are congruent, and we could find out this one as well because they are supplementary. Okay, let's do one with, last one with angles. Example 3. Let's say we have trapezoid. I'm going to purposely make this upside down. We're still going to have parallel sides. We have Q, R, S, and T. And I know that this angle is 6x minus 22. And this is going to be 8x plus 34. So these are not opposite angles, but because they are parallel lines, we still know that these are consecutive. That means we can set them equal to each other. We get 2x equal to a, subtract, something happened, 6x, 8x plus 34. Oh, hold on. Hold the phone here. This is not right. These are not equal to each other. I'm losing my marbles. What is the relationship? They are supplementary. Good grief. 6x minus 22 plus 8x plus 34 equals 180. Combining like terms, you get 14x. Combining like terms of your constants, and you get positive 12. Solving, so I'm going to subtract 12 on both sides. And I get 14x to equal 168. And then divide both sides by 14. And x equals 12. Holy moly, glad I got through that one.